Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad HAKIMI bin Makrozi. Now I will present about our mini project MEC 351. So we have been assigned to choose any building such as mosque with minimum build-up area 3000 square feet and construct a two-dimension floor plan for the chosen building by using CAD software. Based on our discussion, we have decided to choose Abdullah Fahim Mosque, which is located at Kepala Batas, Pulau Pinang. This is because the build-up area for this mosque are fulfilled with our mini project requirements. Now I will continue the presentation with our objective for our mini project. For the first objective is to identify and analyze the actual grand total heat of the selected area, such as library, meeting room, classroom, which is located inside the mosque. Okay, for the second objective is to propose the best air conditioning system for the selected area based on the calculation of grand total heat, either split, multi-split, central air, and package air conditioner. For the third objective is to design the air conditioning system for the selected area. So based on our result in calculating the grand total heat, there are different model of air conditioner going to be used. This is because to let the air conditioner operate efficiently, we need to know the rate cooling capacity for the space. Then we will find the air conditioner which is suitable with the rate cooling capacity of the space. From that, the wasting of energy can be prevented. Now I will explain about our scope project. The project is about calculating the amount of air conditioner need to be used for the selected area. The second is expose the student to get experience in identify the best type of air conditioning system going to be used. The purpose we calculate the amount of air conditioner need to be used for the selected area to let the space cool efficiently.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti ATHIRAH binti Ibrahim. Today I want to present about our mini project. First, I want to explain about the procedure or the step that we use to perform this mini project. First, we choose the suitable building, which is Masjid Abdullah Fahim, and then we measure the scale, and then we design the building using AutoCAD. After that, we calculate the area of each room. Basically, the room is include the library, bilik mesyuarat, pejabat Qariah, bilik imam, and class 1 and 2. And after we finish calculate the area, cooling load is calculated using cooling load estimation, and we finding the suitable air conditioning system for each room. After that, we include the design with ducting, AHU, FCU, and others. And the last one is we finish designing the building. Next, I want to explain about the introduction. Basically, this mini project is to analyze and evaluate the grand total of cooling load and propose the selected design to achieve thermal comfort for the chosen of building. Heating and cooling load as calculation are carried out to estimate the required capacity of heating and cooling system, which can maintain the required condition in the conditional space. Cooling load calculation is to determine the optimum rate at which heat needed to be removed from space. It becomes to establish thermal equilibrium and maintain a predetermined inside condition. Now we move to the next, which is estimation cooling load for the library. Basically, this room use equipment operation of this is 12 hours per day. Its area is 119.179 square feet. The occupancy of this room is 20 people, and the equipment used is 2 computers with 50 watt each. The air change is 1 air change per hour. So based on the estimation cooling load that you can see in the report, the grand total heat is 73,011.713 BTU per hour. Next is for pejabat Korea. It also used for 12 hours per day, and the occupancy is also 20 people. It used 3 computers with 50 watt per each. And the air change is also 1 air change per hour. And so based on the estimation load that you can see in our report, the grand total heat is for pejabat Korea is 97,919.429 BTU per hour. Okay, I think that's all from me. Thank you. Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Hajar ATHIRAH binti Ibrahim. Today I want to present about our mini project. First, I want to explain about the procedure or the step that we use to perform this mini project. First, we choose the suitable building, which is Masjid Abdullah Fahim, and then we measure the scale, and then we design the building using AutoCAD. After that, we calculate the area of each room. Basically, the room is include the library, bilik mesyuarat, pejabat Korea, bilik imam, and class 1 and 2. And after we finish calculate the area, cooling load is calculated using cooling load estimation, and we finding the suitable air conditioning system for each room. After that, we include the design with ducting, AHU, FCU, and others. And the last one is we finish designing the building. Next, I want to explain about the introduction. Basically, this mini project is to analyze and evaluate the grand total of cooling load and propose the selected design to achieve thermal comfort for the chosen of building. Heating and cooling load as calculation are carried out to estimate the required capacity of heating and cooling system, which can maintain the required condition in the conditional space. Cooling load calculation is to determine the optimum rate at which heat needed to be removed from space. It becomes to establish thermal equilibrium and maintain a predetermined inside condition. Now, we move to the next, which is estimation cooling load for the library. Basically, this room use equipment operation of this is 12 hours per day. Its area is 119.179 square feet. The occupancy of this room is 20 people, and the equipment used is 2 computers with 50 watt each. The air change is 1 air change per hour. So based on the estimation cooling load that you can see in the report, the grand total heat is 73,011.713 BTU per hour. Next is for pejabat Korea. It also used for 12 hours per day, and the occupancy is also 20 people. It used 3 computers with 50 watt per each. And the air change is also 1 air change per hour. And so based on the estimation load that you can see in our report, the grand total heat is for pejabat Korea is 97,919.429 BTU per hour. Okay, I think that's all from me. Thank you.
Assalamualaikum. Go to the methodology. For method for calculation, we're going to be using two methods, which are cooling load temperature difference for cooling load estimation and equal friction method for the duct design. So we're going to talk about the CLTD method first. The first step is to find the dry bulb temperature outside of the rooms and inside of the rooms. Next, using the psychrometric chart, we can determine the value for specific humidity and relative humidity for all the rooms. To calculate the CFM, we multiplying the number of people with CFM per person, area of the room times with CFM per square feet, and the third one, air change per hour, multiply with volume over 60. Among the three values, we choose the highest values as our CFM value. For the calculation of the solar heat, we will find the area for wall and glass for each direction for solar heat gain. For wall, the area of the wall must be multiplied by equivalent temperature difference in table 7 and transmission coefficient in table 9 and sum up the total. The same method applied to the glass, where the area of the wall is multiplied by the value in table 4, table 5 and table 6. Okay, for the calculation of the transmission heat gain, we divide the walls into external and internal walls and will be dependent on the direction of north, east, south and west. So after getting all the values, we will calculate the value for effective room sensible heat and effective latent room heat. These values are then summed up and the grand total heat is calculated by adding up all the values in the boxes in the chart. Okay, next one is equal friction method for the duct design. The first step is we will calculate the CFM by dividing the total RSH with 1.09 multiplied by difference of temperature. Then we will find the required divisor by dividing CFM with CFM per divisor that has been selected. Find the CFM by multiplying the number of divisor has been used. Then we draw a schematic of ducting system, arrange the divisor and make sure all the space is covered with area of the divisor. Then we determine the ducting size by fill up the table. So we need to find the CFM, HF, FAM, diameter of round duct, and dimension rectangular duct for each section. Then lastly, we will sum up the total friction, which is HF. So for procedures of designing a full air conditioning system to the building there is 10 steps. The first one is calculate the cooling load for each room. Then we identify the best air conditioning system to install for the building. Identify the component that needed to install in the air conditioning system. Then we select the suitable unit with required air cooling load. Then we will use the catalog to identify the best unit, calculate the CFM and arrange the divisor. Find the best arrangement of the ducting system. Choose whether you want to use AHU or FCU in the system. Choose the types of chiller water system, whether air cooled or water cooled. The last one is sketch the installation of the all unit in the drawing and label with its specification to make the apparatus easy to install it. For the assumption of design requirement, we assume the height from the floor to the ceiling about 12 feet and maximum operation of 12 hours. The roof materials is corrugated asbestos sheet with suspended ceiling boards. The room condition is 75 degree Fahrenheit, 55% relative humidity and 72 grain per pound. For the outside air, 92 degree Fahrenheit, 60% relative humidity and 136 grain per pound. For the air change, 1 air change per hour. And for the heat source, maximum people for the building is 1,500 people. The window is directly get sunlight west and east. The appliance used in the building is computer, projector, amplifier, and LED television. For the building materials, the walls is using 4.5-inch brick wall with cement plaster on both sides. The window glass is using regular plate, 1/4-inch, shade of medium color. And the doors, there are two types of doors, which are glass and wood. For the roof, the material is corrugated asbestos sheet with suspended ceiling boards. Lighting is incandescent type with 7 watts square per feet, and the ceiling is plaster ceiling. That's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad FIRDAUS Muhammad Shukri, and I'm here to explain about the result discussion that we have found. Based on our calculation, the cooling load of the play area at the first floor of Masjid Abdullah Fahim is 6,686,090 BTU per hour. We are corporately to choose air-cooled chiller system as air conditioning system design. There are many factors that affect cooling load from external and internal load. Most of the load come from people, lighting, electrical appliance, solar heat, outdoor air for ventilation purpose, and other. The area of the play area is 27,207. When we design and choose any type of air conditioning system, we must consider all factors of cooling load that become our reference to choose equipment and component of air conditioning system. The first one, we have choose a diffuser. Diffuser is a device for reducing the velocity and increasing the static pressure of a fluid passing through a system. Diffuser is important especially in centralized air conditioning system, and diffuser are used on both all air and air water HVAC system as part of room air distribution subsystem. Here is purpose of diffuser: to distribute the flow air to the desired place, to flow the air conditioning and ventilating air, to mixing of air of room air into the primary air that being discharged, to minimize the noise in the system, and to create low velocity air movement in the occupied portion of area. The next one is AHU, also known as air handling unit. Air handling unit, it is a device used to conditioning and circulate air in air conditioning system. AHU usually a large metal box containing blower, heating and cooling element, filter rack or chamber, and damper. Air handler usually connect to ductwork and distribute to the conditioned air to the building and return it to the AHU. The next one is the advantages of AHU. AHU is used over the bigger space, and FCU is usually used for small space. Large buildings that have multiple rooms need AHU to deliver air evenly through. FCU also relies on the air already inside a building rather than pulling in fresh oxygen from the outside. The next is the chiller water system. In chiller water system, the entire air condition is installed on the roof or behind the building. It cools water to between 40 and 45 degree Fahrenheit, which means 4.4 and 7.2 degrees Celsius. The chilled water is then piped throughout the building and connected to air handler. This can be a versatile system where the water pipe works like the evaporator coil in a standard air conditioning. If it's well insulated, there is no practical distance limitation to the length of the chilled water pipe. Next, system selection and justification. To choose the right system for the play area, we must first know the grand total value, which means GTH of heat of the area, and after summing up all value of GTH, we managed to get the value of 6,686,090 BTU per hour. Based on the value of GTH, we have identified that centralized air conditioning system is the most suitable system to be used at the floor. Central air conditioning systems are used for where the cooling load are very large. After calculation has been made, we have identified that 1 chiller, 1 AHU, and 12 diffuser is needed to cover the capacity of cooling load required for our floor area. Besides that, the reason we have chosen the packaged air conditioning system is because it has many advantages. A central air conditioning system offers many advantages over conventional air conditioning system. Undoubtedly, central air is one of the most effective and efficient way to recirculate air throughout the area in comparison to window air conditioning system. The system filters the air that passes through it and removes airborne particles. Filter air is the reroute back to the room via the separate ductwork system. Lastly, the AHU and chiller unit, we choose the cooling capacity that is produced can cover the total cooling capacity needed for the play area Masjid Abdullah Fahim. which is 500 kilowatt for the air handling unit and 580 kilowatt for the chiller. For the diffuser system, we have choose the rectangular ducting diffuser. This is because rectangular duct take up less height, so there will be more space available rather than using circular duct. Moreover, rectangular ducting diffuser works better for low pressure system. That's it. Thank you.
Assalamualaikum. My name is Muhammad Alif. So today I'm going to present about the cooling load estimation table. The cooling load estimation table I use for identify the cooling load for certain space such as meeting room, store, and the prayer space. So I'm give you task to calculate the space used for meeting room, and the equipment operation is 12 hours per day, and the size is 582 square feet, and for the volume of the meeting room is 9964 cubic feet, and the solar heat gain, transmission heat gain, and internal heat are identified by the calculation by following the table. And so for the grand total heat for this meeting room was 967,542. So that's for the grand total heat. And other than that, by calculating the estimation table, cooling load estimation table, we identify the aircon suitable for this room, and the model was a Daikin FTKS71J, and that's for the general model. And for indoor unit, FTKS85JVMG9, that's for indoor unit. And for outdoor unit, RKS85JVMG, and the power is 29,000 for the BTU per hour. That's the average number. And for the minimum requirement is 10,200 BTU per hour, and the maximum 33,000 BTU per hour. So that's for aircon. And for conclusion is, as a conclusion, the task to build an air conditioning system are complete. The project will design aircon system for the Masjid Abdullah Al Fahim. In order to design air conditioning system, assumption analysis calculated the grand total cooling load for each rooms. The grand total cooling load will be guided in choosing model of conditioning air and the efficient amount of cool air needed. The centralized air conditioning system for the prayer hall, and the split system conditioner for this masjid. Based on the result, the centralized and the split air conditioner are most suitable for this building. The cooling load of the building depends on the local climate, thermal characteristic of material, and type of building. Oh, that's okay. That's all for me.